start now. So I'd like to welcome you along to the May meeting, and I'd like to also thank our speaker very much for turning up. Dr. Carl Seubert is actually the Chief Research Officer of SmartSat CRC, and Carl originally comes from Sydney, where he actually was a attendee of the University of Sydney. He got his qualifications there, and then he went over to work for NASA for a few years. And he's since come back to Australia, I think it was middle of last year, I think Tim Parsons was telling me. And now he's actually working for SmartSat CRC on some of the activities focusing on Australian space activities. And Carl will probably also mention this, how things will have changed from when he'd left, actually, in terms of what activities are happening in Australia. So I'm looking very much forward tonight to see Carl's input on this. Well, everyone, welcome Carl. Thanks.
Thanks, Wayne, and hi everyone. This is a privilege to chat, and I'm really happy to kind of just dive into a few different things tonight. I'll touch on just what you mentioned there, Wayne. It was 17 years ago now that I left Australia and went over to the States, and as you said, did my graduate degrees over there, and then had the fortune of working almost a decade at NASA JPL. And the feather in my cap was the Europa Clipper, hence the picture here that I worked on, and I'll talk about that in a minute as well. I think this group will enjoy some of the stories and activities I got involved with. But yeah, most certainly, I think the core reason I left at the time was because I just had a passion for doing more space learning, more education, really wanted to do a PhD in it. And what I could do in the States was just amazing. There was very limited here in Australia at the time. Excuse me. And but now things are flourishing, things are taking off, and I had a meeting just internally with work, and I'm going to have this very informal tonight, everyone, and please don't hesitate to interrupt. This is a chance to have a chat and talk about some good space stuff, so don't hesitate. Forgive me, I have a tickle. And I've lost my train of thought where I was going there. Let's jump into it. So I'm really, just last week I was chatting with my internal team, and we're talking about how, Australia has just some brilliant ambitions. We have a lot of drive to do more space. And I think there's been a well-established drive to do space now for a long time. And that, goes back to AusSat, FedSat, all sorts of good foundational pioneering efforts in the space, and now finally things are really starting to take off. We've got good funding coming in. The research in our universities is brilliant, second to none. We've got that drive and ambition, and now we've got the industry sort of following along to really make it happen and drive it into a true space industry that we want. So it's an exciting time. We're all really getting into it. Unfortunately, my place here at SmartSat's given me an opportunity to really drive our research and technology efforts, and really drive them towards, enabling missions that I think we all care about and want to get behind here in Australia. And I'm going to talk about those today and what those look like. But let me backtrack a little bit first. So I'll talk here about perhaps my opportunities that I had at JPL, because I think this group would enjoy it. And I open it to questions. Please don't hesitate to jump in.
Right.
Go ahead. Oh, I must be hearing things. Forgive me. So I did my PhD in spacecraft formation flight, and how we can utilize effectively control algorithms coupled with electrostatics to do very precise and close formation flight of spacecraft. And really what that enables us to do is open up the opportunities for all sorts of things. Really, we're looking at Earth science and how you can use now close formations to do Earth science. And that really led me to my position and opportunities at JPL, where I joined in the guidance and control group there. There's roughly 100 engineers working on guidance and control problems. And I had the opportunity to run a number of activities in formation flight and how we could use multiple spacecraft to enable the future missions for NASA. One of those, a big one there in the bottom right, is the Starshade mission. This was really fun for the astronomers in this group. This allows us to directly image exoplanets around stars. And we do that by flying these spacecraft at about 50,000 kilometers apart. But the spacecraft, the telescope there, is sitting in the shadow that's made by that occulter, by the starshade itself. So I was looking at that problem and how we could solve that in both the sensing and the hardware side of it, but also in the control algorithms. So it was a fun problem and something that we'll strive to do and will eventually fly in the not too far future. As part of my job there in Formation Flight, I got to run and took over the formation control test bed. That's up here in the right-hand side. This is actually me next to my two robotic spacecraft that we ran there in the lab. These were air-bearing spacecraft. They had 5 degrees of frictionless motion. So we could fly these as if they were spacecraft in space, similar dynamics at least, but with very much terrestrial components. And it allowed us to test our algorithms. It was a technology development lab. So we could test our algorithms, we could test our sensors and develop, again, the technologies we needed for the future missions for NASA. One really fun project that we did with that was the Comet sample return technology development. That's over here on the right-hand side. And this is sitting out the front here is a huge, big sampling arm that was developed at JPL. 2 big titanium blades that would be cut into the ice. And what I did for this was actually take vision navigation technologies that we were developing for Mars landing and actually applied it now to the Comet sample autonomous landing, sample capture, and fly away. So in my lab, we did a demonstration where we actually flew in under this vision navigation system, took the sample, and then flew back out, all fully autonomous. There's no human in the loop here to do this. So that was a good, fun experiment and a lot of fun along the way. Excuse me, as part of that, it's kind of another extension was a program I ran, which was called Cobalt. This is a Maston rocket. This is a group of aerospace engineers flying out of Mojave, which is a couple hours north of LA. And they have these rockets and they're a great test bed platform. And on top of the rocket here is actually our JPL, NASA Langley and NASA Johnson combined payload. And on this payload, again, was a vision navigation sensor suite. So hanging off the side here of the rocket is actually all of the images and our payload pieces. There's 3 pencil beam LiDARs that are sitting on that. There's a camera and there's an IMU sitting up here, and then all of the processing elements inside of it here. And what we were doing here, again, was developing technologies for, in this case, for landing, pinpoint landing, or if we were to go back to the moon or to Mars or to other future planets. So this one was really a demonstration mission where we combined these different sensors. We took the NASA Langley LiDAR, combined it with the JPL vision navigation, put it all together, and actually flew it out here in the desert where we were doing these demonstrations of landing and just determining how well we could actually position the spacecraft during its autonomous landing. Really great program, a lot of good people. It was a really good experience. And again, developing technologies for future landing missions. You can see the common theme here in my speech. And finally, a fun one for me, which was the development of the attitude control algorithms for the Europa Clipper mission. And those not familiar with it, this is a beast of a spacecraft. These panels are huge. That's bigger than a basketball field. These booms hanging off here are actually ice penetrating radar, big magnetometer boom hanging off here. This thing was full of instruments, spectrometers, images, magnetometers, radars in multiple wavelengths, and really great spacecraft headed to Jupiter. Well, hopefully it's launching soon in a few years' time, and it'll take quite a while though to get there. I think the latest effort is 7 years. But really exciting. I got to do the attitude control of that. So my algorithms are headed to space, which is really fun and exciting, and really good opportunity to learn how to do spacecraft development, flight development at JPL. So that was my sort of span of all the exciting things I did at JPL. And really that set me up then to come back to Australia now, where I'm developing through SmartSat, the research and technology portfolio to enable future missions for Australia. So this is a SmartSat sort of derived speech. So you'll see a bit of shout out here to SmartSat and what we're doing in SmartSat and what I'm driving in our portfolio as a chief researcher. But I'll also talk about some applications and things that I think will be interesting to this group. So for those not familiar, SmartSat's over 100 partners that are all contributing and and we have already developed over 80 projects. There's a lot of projects under our belt. Some of those are just small, to be honest. There's roughly about 30 of them that are kind of small projects. And then there's also 37 PhDs on top of that. We're looking to bolster that. Actually, we've got a lot more PhDs in our allocation and build that up. We have 3 state nodes and hubs. One of those is that New South Wales node. That's where Tim and I are based here in Sydney, as we're headquartered in Adelaide. We have 4 professorial chairs and looking at another 3 or 4 to be allocated as well. So it's a good portfolio of research across our university industry. We've got a good chunk of money to put towards research and technology development. Just to put a picture to that, here's a quick snapshot of all of our partners. In the center there are our core partners, our main contributors, and then it sort of goes outward from there. We have a really big Aurora set, and Aurora is our startup and small enterprise consortium. That's actually run as a completely independent, but with under the SmartSat umbrella. And that's an opportunity where we can actually now garner more development in our small industries and our startups by combining them into our bigger industry partners and universities to do this sort of collaborative research, which is what we're here to do as a CRC. And then on the outside is the interaction we have with the international parties for collaboration and input there. So that's really what drives the backbone of SmartSat. It's all based around our technology roadmap. Now, this roadmap is really just the foundation of where we're going to put our resources through the CRC. Now, this is driven not necessarily by what should be innovative or good technology. It's actually, that is part of the case, but often a lot of it is really based on where do we have already good strengths that we can build upon within Australia. And there's 3 core areas that we've really driven and drive our portfolio of research. One is around the advanced connectivity, communications, and the Internet of Things, and how we can use spacecraft and the space environment to support that and grow that. The second one is all about the advanced systems. So this captures everything from the hardware, the upstream side of the thing of spacecraft development, and the applications of those hardware to make spacecraft smarter, more intelligent, hence our name SmartSat, and where autonomy and AI plays in that realm. And thirdly, it's all around the downstream side of it, which is where we can use EO data analytics to really improve our information sources, improve our management and decision-making by using spacecraft and their sensing wisely. And there's a big portfolio of work that we have in that area. So this is really our roadmap in these 3 core areas, and that drives sort of where our technology comes from. And I'll talk a little bit more about where we're trying to go with our technology as our targeted endpoints. Before I do that though, I'm gonna set up some problems or at least some real use cases, because I think what's really important is that while we are a CRC that's intended to develop research, it's R&D driven, excuse me. I think what's really important to all of us and many of us is that we're still solving problems and we're still doing things that are relevant for Australia and Australians as a whole and our communities. So we're really trying to drive our research towards end goals and net targets. I'm going to start here with one of them, which is Waragamba Dam. You know, we're really fortunate it's overflowing right now with our La Nina year. And this water supply is immense. Just a few stats for you, because I think these are pretty amazing. You know, there's 5 million people that rely on Waragamba for its water here in Sydney. The volume of water in Waragamba is actually 4 times greater than Sydney Harbour itself, which I thought was amazing and remarkable, because Sydney Harbour is a monster itself. So this is a huge water supply, and it makes you think things like what would happen if this were to be polluted or contaminated, and how now could you use spacecraft to actually be monitoring this and doing it remotely from space, or how could that augment it? Now, perhaps Waragamba is not the greatest example of that, because we already have very good monitoring of it. In fact, that's what Sydney Water is going to do. But there's waterways across Australia supplying all of our communities. And it's a big task and an undertaking to make sure that water is kept safe and maintained to the highest qualities that we need. So this is just an example of a use case that will now make sense when I talk about Aqua Watch and a mission that we're working on. Another thing that's really relevant, and this is, you know, something that came up just recently, which is the effects of climate change and that effects on Australia and its communities. And I think we all just saw back in late February, the Lismore Floods. These were 2 meters higher than anything that's been recorded, which is just remarkable. There's this great plot that actually came from Lismore Council. You can see the level of the water here in this McDonald's sign here. You know, it's all the way up there at the drive-through. It's just immense, the amount of water that was actually there. And what's key here is that not that we can solve this from space. We do have some good projects that are looking at water and floods, real-time flooding, particularly one looking at the use of SAR and those technologies to map this in real time, supporting our emergency services. But what's also important here is how can we use perhaps connectivity to solve problems that arise when we do have these sorts of emergency situations. One quick example that I want to dive into here, because I think it's quite relevant and something we're trying to solve right now, which is, you know, the SES, they go in and help out when we have these emergencies. And they actually do door-to-door knocking to notify people and support people in the time of these emergencies. And it can take, in a place like Lismore, which is 30,000 people, up to 2 weeks to go and actually get to people that might have been isolated for the whole time in a flooding event. There's also things like right now, actually, the power supply in some businesses is still out. We're 2 months later, and they don't have connectivity. They don't even have power. So there's a lot of these sorts of challenges that we're just going to see more and more often. And what we're asking here at SmartSat is, well, how can we solve some of these challenges using perhaps space technologies? Is there a problem that could be solved or made easier with that? And we do think that in this case, if you had 30,000 people, you'd need perhaps 1,000 volunteers if you wanted to do door-to-door knocking through that town within perhaps a day, which is sort of the relevant timeframes we're looking at here. Right now, that's not feasible. But maybe we could do that if we had some sort of level of connectivity, and we could utilize spacecraft and that connectivity for it. There's also the search and rescue piece. I'm going to talk about that. It's going to be one of the themes throughout today's presentation. So really the question that we're trying to solve is there, in this satellite connected world that we live in, how can we improve connectivity and connections for emergency services? So I'll talk about that some more. So that leads me to our targets here, that what we're sort of driving our technology towards, and that's our capability demonstrators. So SmartSat came along before the agency, just a little bit before the agency. And now we have the national, missions that we're talking about, and I'll touch on those a little bit later as well. But before that, we were driving our technology. We're really what I call a technology push towards what we thought were relevant and vital pieces of missions for Australia. While it's great to do sort of siloed research and do good R&D that's based on universities developing good innovative technology, we wanted to take that and still try to drive it towards missions that mattered, so we could demonstrate them. Now, SmartSat doesn't have the funds to demonstrate missions. That's not in our wheelhouse. We're here still to do collaborative research, but we still wanted to have that end goal. So I mentioned water quality, and one of the missions we're doing with CSIRO as our co-partner on this is the Aqua mission. And this is really about safeguarding our water. And I'll talk about that in a little bit more detail in the next slide. I then also mentioned the emergency management and the prevalence now of climate change based effects, and how we can really handle emergency management and support our disaster management services using space technologies. And that's all fits under the umbrella and eye in the sky. Now, I don't actually see this as being a dedicated mission. I think there's some core problems or challenges that we can try to solve through SmartSat and our partners to really address those in key pieces of technology that might utilize space. And thirdly, another one I'm going to talk about today is Indo-Pacific Connector, the IPC. And this one is really about communications and situational awareness for defense. This is our defense and national security driven mission. DST is actually our biggest contributor, our chorus partner, I guess you could say. And we work very closely with them in driving this capabilities to enable missions that they care about, and then ultimately would get implemented and operationalized, and our partners along the way for defense. And I'll talk a little bit more about that mission as well and what they look like. So Aqua Australia, this is really a great mission. This actually does feature in the air roadmap, and we'll build upon some of the aspects that are being developed in our national mission series through the ASA. And this is really all about how we can utilize both in-situ sensors and a dedicated set of spacecraft with onboard sensors to do water quality mapping and measurements fused together. So we're spending a lot of effort right now on architecting this mission, developing the ground segment, setting up pilots to actually demonstrate this, and then a lot of data analytics, data handling to actually put that infrastructure in place. So Australia can actually really lead the charge and be a good contributor, a good solid contributor to the bigger international water quality management sector. This is a really neat thing. There's, as you know, water is vital to us, as to us all, and it's something that's really focusing on water quality management from space. So this is something we're working with CSIRO, a lot of work and effort going on here, and something that will continue to go on. IPC, this one's a little bit bit more of an architectural sort of image, this one, but this is really about how we can now put defense with sovereign capabilities in our space development segment into sort of the next realm of connectivity and communications. And where we see that going is by using smaller and smarter fractionated spacecraft. So not having single geo spacecraft, but now going to perhaps a smaller LEO constellation connected with medium Earth orbit spacecraft supporting it, augmenting what is already existing in the geo classic sort of SATCOM world. These spacecraft could have smarts on board, not only just AI in terms of their payloads, but also in terms of their operations. They can have ISR and imaging capability, but also a big part of it is connectivity. We have a number of projects right now with DST setting up Australian businesses to support this future effort. And IPC is our version of a technology demonstration mission. And really that feeds in perfectly into the RMS Starshot that DST is running. And we're working closely with DST to show how we can take our technologies and demonstrate that on that mission. An example of that, and this is something that I've been working closely with my CD lead and my team at SmartSat, is architecting this mission of what it could look like. And excuse me. Forgive me. Awfully sorry about that. I had a PCR test and it was negative. We're all at home, thankfully, anyway. This is our concept for IPC, and this is the first version of it, which is really the communications demonstration piece. And what I'm showing here is how we're architecting now and taking our technologies. So I mentioned the technology push. This is now how we craft that, push that into what we think is a capability demonstrator, in this case, based around comms. So we have projects right now supporting the tactical RF, the low data rate comms. We have some in the medium data rate, and actually one in particular called Chorus, which is actually a deployable piece ground segment, which features both an X-band RF along with a optical terminal. So you have the best of both worlds there in a single package. And then thirdly is in the high data rate and going now to the future of optical comms. And excuse me, that's also not just optical comms, but now going into the full coherent optical comms with really high data rate. And some projects we're doing around all of these segments now. And now how do we put these together and demonstrate them on a mission? And what do we need on the space side to support that? So this is that comms architecture that we're setting up and really working with DST to demonstrate how these technologies built out of Australian collaborative efforts could be demonstrated for defense through a Starshot mission, perhaps. Also looking at the future of now, well, how do we do this with sensing payloads? How do we do this now with autonomy, onboard AI payloads, and developing again the projects that would support these efforts and ultimately be positioned for defense of the future. So that's what we're doing with IPC and defense. Going now to the eye in the sky finally. This is really like I said, not necessarily a mission. This is more about how can we solve some key pieces for the emergency management sector. There's a lot of effort right now and a lot of interest, I guess. So momentum building is the right term around the fire escape, for instance. We have a handful of projects right now where we're supporting the data analytics, also supporting some upstream side. So how could you develop sensors that would actually be specifically focused to Australian forests and the fuel loads in our forests? So we're handling a lot of projects right now that is really tackling some key pieces and direct pieces in that emergency sector and climate change piece. It's also about the connectivity. And I'm going to come back to the connectivity piece as well, and that falls under the search and rescue piece. And there's a really interesting use case there that I'm going to talk about, and how we started with a really great little technology widget that's kind of exploded and expanded into some really cool things. So I'll talk about that in a minute as well. And this is also about not just spacecraft, but how do we now tie this into other realms where it is drones, UAVs, high altitude balloons? Where does this all play in this scape? How do we architect this in a way and really solve the problems we care about in this and support the Australian efforts here? Because there's a number of different agencies looking at this, as well as private groups and companies looking at this as well. So it's more about how do we support those efforts and really tackle some small niche pieces in that with space technologies. So that's our capability demonstrators. It really is just a framework for us, an end target for us to shape our and drive our research and technology efforts towards. And that just gives us that target end goal. So now not only are we doing a technology push, now we can do a technology pull and enable these missions with those technologies and place our partners to contribute to these national efforts. Now, where do those national efforts fit in? What I'm going to show on the next slide is something you're all probably familiar with, which is the EO roadmap. And what's circled here is the green in the green circles is the projects we're already funding through SmartSat, and that might be multiple projects in there. The red ones are ones where we're actually doing some effort, or there might be some work already ongoing that would perhaps have tie over or place our partners to build upon and support those efforts. So you can already see here there's a number of different projects and pieces here that fit into these national missions. So while I said we sort of started out with a technology push, having these end goals and having these targets now lines us up with these roadmaps, and ultimately lines us up to putting those technologies onto missions that will be funded and ultimately become operational. And then, as we all hope, turning it into a real space industry with commercial opportunities as well. So that's really what's driving us. So that's where it fits into that bigger national piece. We could do the same for the comms roadmap. I don't have that here, but the comms roadmap has a lot of overlap. We've got a lot of great projects in the comms world. And that's where also too, we can touch on the defense and civil overlaps and these dual use technology pieces. And that's really something that we're very aware of and work towards at SmartSat and bringing those together. And that's where things like the SSU that's coming up is really important, I think, in an ecosystem like Australia's, where we're starting out at the sort of the ground floor and building up and doing that with a limited resource pool as well, limited knowledge base as well, and doing that in a way that's both relevant to civil and the defense side, I think is completely valuable. So it's good to see that that's happening, and that's something we very much do at SmartSat. Another mission I just want to touch on here, it's just something we've been working on for some time, is Canyini. This started out at SASat, and this is really, I think, a good example of a state government here in SA jumping in and said, yep, I want to build industry, and here's some money to do a mission to demonstrate that. This is really about driving Innovore's and Myriada's relationship in a space mission. Innovore's doing the spacecraft bus, they're small satellite developers and providers, and Myriada's doing some space payloads here in their IoT connectivity, hence all the antennas hanging off this spacecraft. And bringing those together with a third payload, or a second payload, I should say, which is a hyperspectral imager that we purchased from Cosine, which is a European company. And it's a really great little hyperspectral imager, has onboard AI capabilities, and really doing a demonstration. This is again a bit of a tech demo and demonstrating to the SA Gov how you can pull it together with multiple parties in the industry in Australia and fly and operate our mission. And what we're doing here at SmartSat is now using this as a research platform. So I have a number of projects. Some of them are doing onboard, or the use of the onboard AI, edge processing, One of them is actually looking at early fire and early smoke detection, and how you can use now a hyperspectral imager and detect it early on board and send out a signal and act on it. So this is, again, tying it back into a solving a problem that fits under that eye in the sky emergency management umbrella. We're also using this as a pathfinder to Aquawatch and water quality management. We have a pilot site for Aquawatch in the Spencer Gulf in north of Adelaide. And we're going to use this now as a direct data fusion of Australian-based EO sensor data, along with the hyperspectral sensor we'll have down in the Gulf there for in-situ sensor measurements, and do some water quality demonstration, excuse me, for the SA Gov. So it's just a great indication of how we pulled together different technologies, pulled together different collaborative partners here to develop a great project and actually solve some problems with it. So it's a really great test platform for us to do that. Excuse me. I'm going to do a quick segue here to something else and then come back to some more interesting things as well. For those not familiar, we were part of the Space Bridge, or the continuing efforts around Space Bridge, which is a UK-Australia effort. You have to forgive me. And this is just one thing I wanted to touch on quickly, because I think there's some really great projects that came of this, and I'm really hoping we can bolster it and continue these sorts of efforts. We had 5 projects with this one. They had a lot of interest. We had over almost 40 projects in total. No, forgive me. It was 45 projects that were submitted to this. So super competitive. There were really some great projects in it. And what I think this is important is where, again, there's some really great Australian research that's coming out of Australia, and had a lot of interest from our UK counterparts to get involved and have a collaborative project where we could build that. And I think this is another example too, where Australia can play in this field if we have core technologies that we can focus on, good bit of research that we can develop and produce, and then where we can show that and garner that, not just with the UK in this case, but across Europe and in the US as well, and other places where we're working right now with India, Japan, and really kind of play on that global scale. So even though we're doing things from perhaps a early days in the space development regime, we've still got that great engine of research in Australia. We've still got some great industry that's really doing some good things, bringing those together through SmartSat collaborative projects and putting it on that global scale. And that's really important. These 5 projects were great. I wish we could have chosen a lot more. You know, we're covering a lot of different topics here. We're pretty broad in terms of our call that went out here. One of them that is already starting to bear fruit is this Calval one that's turned into a big effort now that's going to go on through SCR, through the national mission. So that was, you know, just a smaller piece that was part of a much bigger picture that Australia is doing. There's a comms one in there. There's a quantum one in there for optical comm. That's another big important one. IceCube is great. This is utilizing the Spire series to do ice monitoring in the Antarctic. And then hyperspectral data, again, applied to, in this case, ag. Really important sector for Australia. And there's a really good opportunity for us to be using space resources, particularly perhaps some Australian ones, our own, so we're not reliant on our international purview and their sensor data. Perhaps we could be doing that with our own data, something that we're investigating right now. So that's just one small piece I wanted to touch on. What I'm going to dive into now is one particular project, because I think this group will really like it. We have a project right now. It actually came out of a company, a small startup, Safety from Space, which is run by Mark Rice, who is a Adelaide-based DST employee. That's his day job, and Safety from Space is kind of his side project that DST allows him to do. He's a comms background by trade, and he did this great project through SmartSat, which was basically looking at how can we do fundamental two-way comms using the existing StarSat. So that's the search and rescue satellite network, which actually piggybacks on GNSS spacecraft using a 406 megahertz connectivity link super low data rates, but super low small packaging. When you typically use this in a search and rescue event, which is the image you see there, it's a one-way distress beacon. So he looked at, well, how can we piggyback on this and do two-way bent pipe connectivity? So at least you could be giving some data and information back to the user. This has kind of grown and expanded. And this first project that we did with him, he did a demonstration. This is where he went out into the Adelaide Hills, demonstrated that out there, and showed that you could do the positioning or the course positioning with it, and this full bi-directional connectivity using a really low weight, size and power module. It was using, just so you know, it was roughly a 0.5 watt power transmitter, and having effectively zero network latency, so you could have connectivity to two mobile connections. Really great, good little project. And now it's kind of expanded, and we're kind of looking at now new options for it. How does this perhaps play in the defense scape? But also what I've got on there is NASA. So what we're doing now with the second follow-on project, is how does this play in NASA Artemis? And I think this is quite relevant because although I was not present, I understand there was New Horizons Summit last week. There was a lot of talk about these sorts of good applications of Artemis and what we can be doing at the moon. This is just a piece of Australian technology that's now garnered interest with NASA, and we're working closely with NASA. They're part of our follow-on project about how could you use this if you had a network at space as a piece of astronaut search and rescue. So this is where you could perhaps have, it would perhaps be an auxiliary system, but this is where you could have two-way connectivity through some network that you perhaps had at Lunar Outpost, and we'll talk about that in a minute, for search and rescue of astronauts, or it could be for localization of vehicles. There's all sorts of different applications that we're kind of looking at there. So that's the follow-on project. It could also expand into terrestrial. So we're stepping away from that 4 and 6 megahertz and now looking at S-band. So now you can also look at other different applications of the moon, which is great. But also now looking at bringing it back and how could we do that perhaps in the terrestrial environment for Australians or defense perhaps. If we had our own network up there and you had the allocation of frequency, could you be doing that now as a two-way messaging communication piece here on Earth? So we're really sort of expanding this. This is, again, just a neat little piece of technology, low bandwidth, low power, just with smart waveforms and allowing you to do search and rescue. And where does that fit into this bigger picture? You know, we're going down the path of LunarNet and LunarSAR, and this is all very much big and driven by NASA, but it's really all about how do we actually play Artemis on the bigger scheme, and where can there be in-kind contributions from our international partners, and where can perhaps Australia play a piece. So maybe this is just one of those pieces where we contribute, we put some effort and some funding behind, and we go ahead and develop this as a supplement or a piece of the LunarSAR piece. But as I mentioned, we're doing a lot of communication work. We're doing a lot of work. There's one of the core technologies we're developing right now is is a optical clock. How does that apply into PNT? Perhaps that's part of this bigger picture of doing navigation at the moon. Perhaps we could even be doing it here on Earth as well. There's optical ground stations. We've got the Australian Optical Ground Station Network coming together, and right now, Australia is really poised in the Southern Hemisphere to be really great for South Pole communications on the moon. Maybe these are just some of those pieces where we can again apply Australian tech, Australian capabilities towards this bigger Artemis mission piece. So these are the kind of bigger picture targets we're looking at. Obviously, we're trying to solve the problems right now in Australia with these national missions, but let's keep looking towards how we can apply these technologies, keep building on them, and look at other opportunities and explore with them. So that's very much where I'm sort of driving us in our technology portfolio. You know, I'm going to wrap up here shortly and allow you to ask questions, but I think what we've sort of talked about here, and this is my slide around Australian space innovation. I think what's important is we ask the true question here, but what does that really mean, innovation, particularly in an Australian R&D ecosystem where we are relatively new to the space endeavors. And I think right now we are sort of more hovering in that lower trajectory where I deem it strengthening and optimizing. We're building on a few key pieces of knowledge and really growing that and pushing that up. We have right now in our portfolio, I think, some projects that have much higher prospects, might go out in that sort of explore and extend realm, maybe even get up into that sort of transform and disruptive stages. And I think what's important there is that we're always doing research and technology where we're trying to target that disruption. We're trying to keep pushing the innovative boundary and looking for opportunities that would give us that sort of that end goal. But I think it's really key, and I think we all agree here, that we continue to have incremental and methodical steps to get there. To me, that is the way of sound research, is you keep plodding along and keep pushing the limits. And it's really important that we keep asking the questions to find the right problems to solve. And I think that's key with that research approach. And I'm seeing that with our partners and the projects we develop. And I think that's really great. And it's really, humbling. And it's done at every level, from our PhDs all the way through to our industry and across government even. I think we're starting to get that right approach of asking the right questions. And I think what's really key here is that we just have to be really supportive of each other and keep doing this collaboratively. I did quote here Stuart Kaufman. This is something I came across recently, this notion of adjacent possible, and I think it could apply here to space technology. And it's this notion of, you keep pushing the limits and keep opening up doors, and it'll open up more doors. It's sort of the nature of innovative research, but it doesn't mean it becomes completely commercialized, or at least impactful, if it's not quite yet ready to be taken on. And I think we have to be cognizant of that in Australia as we start lifting off the launch pad here and getting into our space pursuits. We have to be realistic here on what we can achieve and should achieve. But we've got to keep aiming high and keep shooting for those stars. I'm a big believer in that. So where do I sort of see us going? And some big steps here in my second to last slide. We're doing a lot on Earth observation. So excited to now, I made this slide before the announcement of the National Space Missions in EO. But we're doing great things here. We have so many projects right now with great research in the downstream data analytics, how we can use these missions and how we can perhaps play a part in flying our own missions here and doing some good things here. And creating that trusted EO data is essential. So that's actually why it's key that, and truth be told, I did make this slide before I even knew about SCR being a mission, because it is key that we have solid data that we can trust, and that whole cowbell piece, and how that plays into the science applications that we want to see here. Connectivity and comms, Australia's been doing great things here, and we're going to continue to do that. We have a big portfolio of work that we're going to demonstrate through DST, hopefully, and ultimately get implemented for defense. How that, though, applies to ground segments for emergency management, how that perhaps even goes to astronaut SNR, for instance. There's a lot of good things we can do here in this space. Something that's near and dear to my heart, which is onboard autonomy, how we can make spacecraft smarter. This, to me, covers a vast range of activities. Everything from the edge processing, got some great companies in Australia doing some of this, all the way through to how do we make spacecraft smarter to make it easier for the operator on the ground. That to me is key. And then how we can go all the way through to constellation management, maybe even autonomous formation flight, bringing it back to my roots and my PhD, and how that extends that space situational awareness piece. But let's all be grounded a little bit here too. I'm a big believer in the space environmentalism. This is where it should be all about sustainability. We have to be really cautious of what we're putting up there. We definitely don't need any more debris up there. So we have to do things right. We have to engineer that change to make sure we are flying spacecraft that are worthy and are actually, doing the right thing and being responsible always. And we have these grand ambitions to be a spacefaring nation, and that's going to start with STEM. That's going to start with generating and the next generation of kids to come up through the ranks, be inspired and passionate about space, like all of us here on this call today, and getting them into that environment, giving them that ambition, that motivation to pursue space. Something that keeps me excited, and I hope my boys get into it too. So I'm going to stop there. I think we have a really exciting future ahead of all of us. Space is really taken off in Oz, and it's exciting to be back. That's why I came back to Australia, left JPL to keep getting involved in space here in Australia, and hope to really craft something that makes sense for everyone and gets us all excited about it. So I'll stop there and take your questions.
Are you going to read out some of the questions from the chat, Wayne?
You're on mute, Wayne.
Sorry, I was on mute. Yeah, okay. Yep. Sorry, first one's from Ken Robinson. Does Aqua Watch include inland waterways, e.g. the Murray River?
Yeah, Ken, absolutely. So Aqua Watch is intended to cover all waterways that it can, from the space segment at least, and that's driven really by GSD and then the resolution of your imaging. But the intent is there to actually cover the major inland waterways, absolutely, and then the coastal waters as well. Quite a large remit, but yeah, most certainly. And actually, we've got a program right now with the Murray River, working closely with them, and a pilot being set up that would support some of these efforts, most certainly.
Anything further
I'm
you
just
want to
seeing
add?
these questions.
Sounds like it's answered it then. Okay, that's good. That's next one's from John Brawley. Could this technology include satellite phone being cheaper and more available here?
I'm assuming you're referring to perhaps the search and rescue stuff. I'll be honest, we're still looking very much at that low bandwidth, low data rate search and rescue piece. This is not about setting up a Starlink and having cheaper sat phone. I don't think that's a realm that we're going to be diving into. That's a good question though. I don't know a lot about sat phones and the use of them, and I really should. If we're going to be solving problems, maybe this is a problem we should be looking at. So thanks for that question, John. I'm gonna dive into that and look at that for you.
We've actually had people asking questions about Starlink, because
Right.
I understand that they've been trialing Starlink in Australia, but of course that's an external provider. So I suppose the question there might be relating to, is Australia doing anything specifically relating to sat phones, or are we looking for external outside providers like Elon Musk, for example?
I don't want it to be indirect message anyway.
So that would be the thing. Anyway, that's good. Scott Marshall's got a question on, in South Australia, there used to be a great space and science capability at Salisbury, that's right. I believe a part of the Department of Defence, that's right, DSTG. Does any of this capability still exist, and can you tap into it? I raised the question because the SA government is sponsoring at least one of your projects.
Yeah, absolutely. And I think you're referring to the Edinburgh facility there. In fact, I was just there last week at DST, and they still have a really great ground segment. Thanks, Wayne. Yeah, that's DSTG. That's both RF. They've just now put up a optical ground station as well. And they're doing a lot of work around comms connectivity out of that facility. And that is a key part in that IPC, that Indo-Pacific Connector demonstration mission that we've been trying to architect. And that would be based around connectivity to that ground station in Adelaide and Edinburgh. DSTG have a couple of missions on the horizon too. So they have Buccaneer main mission, which is a CubeSat demonstration. It's actually going to fly both an RF and a optical payload, and that will be operated out of DSTG there in Adelaide. So good question. And they're very much a player in this. In fact, part of that, I mentioned the Australian Optical Ground Station Network. That's a really neat thing. They have there's one at UWA in Western Australia. There's one there in Edinburgh that's included, which is the DSTG one. There's one at ANU and one in New Zealand as well. And there's talk of perhaps more. And DSTG and their facility is part of that network. So yeah, it's a great question. Thanks for that one, Scott.
Anne's got a question on in regards to emergency communications, maybe access to personal beacons for cars, IGUS, etc. Yeah, that's probably right. What you're looking at there.
Yeah, so I was just wondering if some of that emergency communications you're talking about would be become more accessible to everyday people for because we do have people who travel remotely, especially since COVID. People are going all over and way out into the bush, and a lot of contractors do work out that very remotely. And if there was better emergency communications for individuals, maybe.
Yeah, it's a great point, Anne. So just a couple of more facts for you. This network that uses the SmartSat network, Australia as a whole is actually the highest per capita user of emergency beacons. So these are just those beacons that you purchase. I couldn't actually tell you what the retail price, but a few $100s I think is all they are now. And the most of them, a good majority of them, are used in actually maritime rescues. And the way they work, if you're not familiar, they send out the ping that goes through the SmartSat network, ends up going to a Australian coordination center. I think there's one in WA and one up in Queensland, I believe still, and then NZ have one too. And then they dispatch an emergency. It's purely a one-way thing though. So if
they could turn those into a two-way thing, to at least the point where they could send back a message saying, yes, we got your beacon, so that somebody would know that help is on the way.
Exactly. And that's exactly that's the problem we're solving. And that's what Mark has demonstrated when he drove through the Adelaide Hills, was the ability to go two-way pinging, and doing it for small technology piece, not too big hardware, low power. And then now what we're applying that to now is the flooding piece. So you could imagine the ability to use and more, rather than just looking at broad map, you could send your cell towers, activity or power anymore. These things are so low power and connected that where that's the sort of problem we're trying to solve with this technology. So yeah, no, you're on the money there, Anne, 100%.
Yeah, sapphires are quite expensive at the moment. I think I was looking at one myself. It's between $350 to $500 to buy. So if we get something that's a bit more cheaper and more useful than what it currently is, it'll probably be a bit more attractive. I had a question, Carl, relating to how SmartSat CRC operates. I see that you're basically a conduit between, I suppose you could say, the universities and private sector. How does SmartSat CRC engage the different university groups when it's trying to work out who's the best fit for doing the research projects? Because it looks like you've got primarily South Australia, but you've also got the Victorian node plus the New South Wales node as well. So there's quite a few universities in the consortium. So it's really probably a matter of how is the coordination work really in the organisation to get the best results.
Yeah, no, we have a huge partner base. Excuse me, as you'll see here, and that spans all of Australia. Most of the core universities are a partner. So there's a few different ways that happens. One, naturally, universities will come to us with unsolicited proposals. That's completely normal, and that will come from them, and we assess them like we would, that they fit against our roadmap, they fit against capability demonstrators. As you said, we are a CRC, and the purview of the CRC is to be collaborative researchers and develop projects that do take research from universities, combine them with industry, turn them into sort of commercial driven products. And that's really what we're here to try to do. So a lot of it is about how you bring those together, the universities with our industry. So unsolicited projects come in, we put out calls and they can then respond to that, and universities across Australia will respond to those ones. Then we go down the path of more targeted, focused technology pool projects. And in that case, we might lean on specific partners that have existing expertise there and try to build on that. We also do things like this last week, we did or a couple of weeks ago, a cognitive radio project, or a development of a project, I should say. And in that case, we had a workshop where we actually pulled in and invited all of our core universities and brought them in to have the discussion and see what they wanted to tackle within that program and what they could offer and contribute to that program as well. So we do approach it a number of different ways and do try to address all of our core partners here and have them engaged in some good technologies. And ultimately, at the end of the day, placing them so that their research and their technologies are driving towards these national missions we care about, these capability demonstration platforms where they can demo that research they've developed, and really putting them in place then to be part of these bigger programs. So Australia now has true industry delivering on missions that we care about, and we'll have ultimately government support, civil or defence side. So yeah, good question, Wayne.
Thanks, Carl. Professor Cairns has asked a question. Carl, you mentioned attitude control using electrostatics. Can you please explain a little bit more on this?
Yeah, most certainly. So my PhD was on the use of electrostatics for formation flight. So if you have a charged spacecraft, and spacecraft in the geo environment in particular naturally charge up to tens of kilovolts, if you can actually control that spacecraft charge, you can now use the Coulomb force between charged spacecraft to manipulate the force between them and actually use that now as the control mechanism. So I did a demonstration where I actually showed one-dimensional Coulomb control, we called it, where we actually charged up spheres and demonstrated closed-loop control as if they were spacecraft flying in a charged environment. Sorry, charging them to control their relative separations in their formation. So that was the principle behind it. I did a lot of work around understanding the plasma interaction with the charged spacecraft. You have these Debye lengths and you have this interaction of the spacecraft with the plasma, which ultimately affects your charging, and then how you can manipulate the spacecraft charge to do that control. So it was a good, fun PhD. I'd be more than happy to talk more about that with you, Eva, and dive into it. It was good fun. It was interesting, actually. Part of the PhD, I mentioned the demonstration. I had a one-dimensional test track, charge these things up, zap myself a few times as well, safely. It's okay, and getting this interaction with the lab environment, so the atmospheric environment, and how these charged particles are actually interacting now, and trying to draw parallels to how that would be a spacecraft in a plasma environment, and how that could actually play in. So I know this is also near and dear to your heart, Eva, understanding that plasma and the electron environment. So happy to talk more in detail in a later date on that one.
Thank you.
I actually had a question on the Europa Clipper, Carl. I saw a picture of it at the beginning there. How large is it? It looks like it's is that a large probe, or how does it compare to some ones that went to Jupiter?
Yeah, it's a beast. Just this piece in here, this is the main spacecraft bus. I'm not going to butcher this. It's multi-ton, and I should know these numbers off the top of my head. I know for a fact that when it was laid out across a basketball court, end to end, this was it was longer than just a basketball court. So this is huge. I believe this stands 3 meters tall, this main spacecraft bus here. This boom sticks out a long way as well. So it is a big spacecraft. It's a flagship mission of NASA's, James Webb-esque style.
Well, Juno probed the
When
last.
is it meant to be there?
Pardon me?
When is it meant to get to Europa?
Last I heard, they were trying to launch 24, and it would take, I think, 7 years to get there. So we're looking at, 2031 plus. Won't be any sooner than that.
There was a story at one stage using SLS for it, and I think the plan was if they ever used it, it would probably reduce it by a third. But at the moment, that's not going.
That's right.
So it's going to be, well, I mean, it'd probably end up being Falcon Heavy or something like an Ariane launch vehicle at this stage to take it up there, I think. And that sounds like it's similar size to Juno, which is probably 3 to 4 ton size. So it's a big probe.
It's a big one. It's quite a bit larger than Juno. And
right.
yeah, it's
going back.
It was, you're right, intended to. We'll go ahead.
Yeah, probably going back to Cassini size or something. Those last ones that were Galileo, and because they were very large probes, and then they started reducing them. They were too big, really, and they gave NASA a lot of problems with, payload capabilities. So I suppose Juno was smaller, but this then is starting to go back to those sides then, Cassini size.
Yeah, no, that's exactly it. This is on the order of a Cassini style. The biggest difference here being that this one has monster solar arrays as opposed to the RTG, which caused plenty of engineering heartaches, I can tell you. This was a big floppy spacecraft, trying to do very precise maneuvering, and I can tell you from an attitude control problem, I had my challenges cut out for me. It would have been perhaps a little bit different story with RTGs, but yeah, no, it's a beast. I'll just looking it up for you as we speak now. Actually, so yeah, the solar panels tip to tip of 22 meters. The launch mass was just over 6 tons, or will be. Payload is on the order of 350 kilos. So it's a big spacecraft.
Yes, I think it's as big as, if not bigger than the other probe by the sound of it, the way you're describing it, if that's the size. Well, that's going to be interesting what we're going to launch it with. Yeah, it's going to
like Falcon Heavy.
Yeah,
is slated, given its SLS won't be ready for it, although there's challenge with SLS. Because it was intended to go SLS, and SLS would have given us a much more, they called it to direct trajectory, because it has a lot more oomph, but we'll have to now do a number of flybys and gravity assists to get out there on a Falcon Heavy, which made its own problems, because now we had to do a flyby of Venus. So we're designing a spacecraft that was operating in a nice cold environment of Jupiter, high radiation though, but now we have to be able to survive a Venus flyby where you get a lot warmer and a lot more sensitive instruments and payloads, and even the solar arrays themselves. So there's a lot of technical challenges there that we had to solve with getting hot at Venus in a flyby and then getting back out to Jupiter. So yeah, it's a lot of different intricacies that we had to engineer out of it.
Yeah, so it looks like in a couple of years' time we're going to be focused on that particular one, which is really good. Yeah, I think the problem with the SLS was that they don't make enough of them in terms of the frequency, and to use up an SLS for that type of mission, I think they decided once they got ambitious with the lunar program that they couldn't use it like the SLS like that. So I think it's quicker to get a Falcon Heavy. Elon's making them a bit more regularly at the moment. The Falcon 9 stages.
I was very fortunate to see a Falcon Heavy, the first night launch from Kennedy, and it was remarkable. It was quite a beast watching those two rockets come back down and land simultaneously too. It was just amazing.
Yes, when we saw it, I remember everybody got really charged up with these things, just came down and landed next to each other, and nothing happened. They were perfectly safe, and then the other one landed as well later on. I think everyone was impressed. That's right. Yeah. Okay. Have we got any other specific questions on the SmartSat CRC, or we might have be done for the night then?
Well, I've got a question about the education piece. So how are you going about that, and what sort of, for instance, Are you doing anything with the Royal Institution of Australia, for instance?
So we have a full dedicated education college, and they support us with a lot of different efforts. We work closely with the Andy Thomas Space Foundation. I'm not familiar with any efforts that we're doing in that realm, though. In particular, I might follow up with you on that one, though, and let's investigate that. I'd be more than happy to. Can we follow up on that one?
Sure. Sounds like a plan.
Do you
Sounds
need
good.
you need Peter's email address?
That'd be great if you could share that after the fact, Wayne.
Yeah,
That'd be great.
We'll loop you both in after that. That's good.
Cheers.
Okay, well, if that's all the questions you've got for tonight, I'd just like to say thank you very much, Carl. I really enjoyed it, and I'm sure everyone else did.
Yeah, my pleasure. That was great. Thank you, everyone.
Excellent talk.
That was
Thank
all.
you.
Yeah, hopefully, it was a bit of a mixed bag. I jumped around, but hopefully giving you some good insight to
You've got
some
a lot
fun
of
things we're working on.
Yeah, you've got a lot of things you're covering, and that's the thing. I'm just trying to work out how. But the slides, particularly showing all the different partners, is the interesting thing. You've got the core partners, and then you've got the lot of people involved. So in itself, there's a lot of things going on in the organisation, and the idea has how you focus on the correct strategy is partly what the aim of the CRC is, to try to sift it through and prioritise. So you're doing policy as well as finding partners. So it's an interesting, collaborative type effort, the way it operates, which is interesting. But I think I have mentioned it to some of the members here tonight, but they really probably didn't understand how active SmartSat is in terms of how many things it's trying to draw together. So it's quite an important organisation, really, in terms of trying to coordinate everything, which is the key thing I was trying to make people understand tonight, which is great. Thanks very much for your time.
Yeah, thank you.
Thank you.
Thank you.
Thank you.
Thank you. And for those people who might want to hang around a bit longer, I've got a couple of things I wanted to show you all, some video. Thanks, Carl. And we might just quickly go through it.